I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore, and today we are going to discuss about Routh-Hurwitz criterion for stability. Before that, remember we have discussed about mathematical modeling of control systems and physiological control systems, time response analysis of first order and second order, and we have discussed about signal flow graphs and root locus techniques, and then we are going to discuss about the RH criterion for stability, Routh-Hurwitz criterion for stability. Okay, see here, root stability criterion, it allows the determination of whether there are any roots of the characteristic equation with positive real parts, and if there are, the number of those roots without actually finding the roots. The necessary but not sufficient condition for a characteristic equation d of s is equal to an s power n plus an minus 1 s power n minus 1 plus etc. plus a1s plus a0 is equal to 0. To have all its roots with negative real parts is that all of the coefficients of ai must exist and have the same sign. If the characteristic equation fails to meet the above condition, then the system is not stable. So the characteristic equation is important. D of s is equal to an s power n plus an minus 1 s power n minus 1 plus etc. plus a1s plus a0 equal to 0. Okay. If Hurwitz condition is satisfied, then root stability criterion must be used to determine the stability of the system. To be able to apply Routh's criterion, Routh's array must be constructed. Begin by labeling the rows with powers of s from the highest power of the denominator polynomial to s0. List the first row every other coefficient starting with the one of the highest power of s. Then the second row coefficients that were skipped in the first row, and complete the rest of the table. That's it. The main thing is, if Hurwitz condition is satisfied, then root stability criterion must be used to determine the stability of the system. And to apply Routh's criterion, Routh's array must be constructed. That is the main thing. See here. Here your input is R of s and output is C of s. Here the transfer function is n of s by a power 4 s power 4 plus a3 s3 plus a2 s square plus a1s plus a0. Here the initial layout for Routh table is s4, s3, s2, s power 1, a4, a2, a0, a3, a1, 0. Like that we have. And Routh array is, first array is s power n, it is equal to an minus 2, an minus 4, an minus 6. Here for s power n minus 1 part, an minus 1, an minus 3, an minus 5, an minus 7. For s power n minus 2, b1, b2, b3, b4. And s power n minus 3, c1, c2, c3 and c4. See here, first s power n minus 1, s power n minus 2, s power n minus 3, like that we have, and finally we have s square, s1, s0. Same thing for an minus 1, b1, c1 etc. k1, l1, m1. And the third part, an minus 2, an minus 3, b2, c2, k2. And the fourth part, an minus 4, an minus 5, b3, c3. And next one is an minus 6, an minus 7, b4, c4, like that. It goes on like this. Here, the value of b1 is equal to an minus 2, an minus 1 minus an minus 3. And divide by an minus 1. b2 is equal to an minus 4, an minus 1 minus an minus 5. Divide by an minus 1. See here, b1 is equal to an minus 2, an minus 1 minus an minus 3 by an minus 1. Your b2 value is an minus 4, an minus 1 minus an minus 5. Divide by an minus 1 from the Routh array. Okay. Here we will classify the stability over here. Here C, an minus 1, b1, c1, k1, l1, m1. The number of roots in the open right of plane is equal to the number of sign changes in the first column of Routh array. Remember that the number of roots in the open right half plane is equal to the number of sign changes in the first column of Routh array. Here the necessary and sufficient condition for a characteristic equation to have all its roots with negative real parts in that the elements of the first column of the Routh array to have the same sign. If the elements of the first column have different signs, then the number of sign changes is equal to the number of roots with positive real parts. This is how RH condition is satisfied and Routh array is constructed. Actually, this RH criterion and root locus techniques are used to calculate the stability of control system. For efficient and fast calculation of stability based on the system application and based on system elements, we can choose the methods to find the stability of control system. Thank you.